So hello everyone, this is NikhilPravat and I am doing a project under S Roy Choudhury sir. My work was to detect a tumor out of MRI image. So I have downloaded the dataset from Kaggle, like you can see here. This is for the yes, where we can see here there are tumors, and this is from no, like these pictures do not have any tumors. These are the normal pictures. So for instance, I have taken two pictures. So this is the normal picture where there is no any tumor here, and this is the picture where we can find the tumor, like we can clearly see there is a tumor. So before going to my approach, what I have done here, let me show you my project. So what is actually happening. So let's run the project, and I have already told you there are two images. This is for no tumor and this there is tumor in here. So I am taking this picture. So here we got the output, like this is the image before processing, and here we have detected a tumor here, and this is the image after processing, like I am encircling it with the yellow line so that we can clearly see it, and here it is the tumor. So let's take the example where there is not any tumor. So let's take it. So I have chosen this image and I open this. So here is the output, like we can clearly see like the image before processing and the image after processing is clearly seen. So what our algorithm was, so let me take you through my algorithm. So what I am doing here, like in the entire picture I am checking the density, like the density of a tumor this region is higher than the density of the normal brain. Like here we can see these are the groups of the brain, and this is the tumor out here. So the solidity of this tumor will be higher than the solidity of the brain, and that is what I am using here. I am trying to find out the solidity. I am trying to find out the region which has got the highest solidity, and I am just trying to filter it. So let me take you my project through my project so that you can easily relate to it. So here I am taking actually inputting the image, taking the input for my image. So let's take it. So here we got a dialog box out here to actually like choose. So for instance I am taking it. So I have got the image. Now what I am doing out here, I am actually trying to convert the image into binary grayscale image with a threshold value 0.7. What does this mean? Does this mean actually the value before 0.7 is totally white, and the value below 0.7 is black, that is considered black. So if we can see here, like the picture that I had chosen, that is for no tumor. So if we convert that image into binary grayscale image and we try to print it, then we see that there is not any 1 here. It means 1 is for vulnerable person, and we clearly see like there is not any 1 out here. So let me take the input let me take the input for that image again. Next image for the tumor image. Sorry. Oh, I'm sorry. And here got the image and take the input. So I have taken the input and now I am trying to convert it. So if you try to print it, then we can clearly see. So let me expand it. So we can clearly see this in these areas, and here these areas that we have got, these are actually the vulnerable portions where we can find out tumors. So this is it for this, and in this area what I'm since if there is not any tumor, then there is no any vulnerability. It means then we are going for this, like image before processing and image after processing is totally same. And in case there is any vulnerability, then we will try to find out like which area has got tumor. So that is what I am doing here. I am actually trying to label it. So labeling will give us the total number of areas where we can find out our tumor. So let's go for this and see what is actually happening. So if I label this and check, then we can see here like we have got total 32. Like it will be counted from 1 to 32, and the pixel 0 that we are watching here, that is actually for background image. So actually we have got total 32 portions of image, slices of image where we can find out our tumor. So BW level has given this. So we are using this property, region props property. So it will help us to get several properties for each region within an image. Like I have already tell you what was my algorithm, and my algorithm was to get that solidity, get the height solidity among the picture in the picture. So this is what I am doing here. Out of the BW, out of the level that I have got, like 32 regions that I have got. So I am actually trying to get the solidity and area for that region. So this is what I am doing out here. So I have got it, and if we try to print it, then we can clearly see there is 32 into 1 structure array, which is for solidity and area. So you can see here, solidity is basically in layman terms we can call the density, and area is area. We already know what is area. So if we try to find the density, then we can clearly see here for all the 32, for 1 to 19 and 20 to 32, for all the 32 regions we have got the density out here. And for area we have got actually what we are getting actually total number of pixels involved. For since we are watching here, the density is highest here, so more number of pixels are involved here. So like this, and this is just for an example that I was showing. So here we have got our density and area, and here what we are doing, this is for actually detection of tumor. Like if we have got a tumor which is in initial stage, then we can decrease its value also, which will be able to pick up small tumors also. And if we want to detect big tumors, then we can increase it. So for instance, I have taken the value as 0.5. So what it will do, it will detect all the, it will check for all the areas, all the densities, and it will give us only those intensities which will be greater than 0.5. So here we can check out here what is this. Sorry for this. So if we high dense area, and if we check this, we have got 1 for all the 32. Like here we can see here, like all the densities are greater than 0.5, that's why we have got 1 for everyone. If there had been any case where the density would not be greater than 0.5, then we have got 0 out here. So out of all the densities, we are trying to find out the maximum density, and here the maximum density, and for maximum density we are trying to find out the maximum area. That is what we are doing out here. So max area we can see here like 3363, and this area has got highest density. As we can see here, this has got highest density. Density is basically this area has got highest density. So we are trying to find out the level here, like tumor level, which level has got the tumor. So if we try to print the tumor label, then it is showing 2. What is this showing? So if we go back and see that there are total 32 there were total 32 portions of the image. So out of these 32 labels were there. Out of this, label 2 contains the tumor. Like I'll show you. Like this is the level. We can see that this is actually a very vast area. So this area is having a tumor, and we can see in the picture here also, like this is also a very big tumor. So this is having a tumor, and so that was done here, and that's how we have got the tumor level. And we are actually trying to get the tumor out here. Is_member with the help of is_member function. Is_member is a function where label 2, since we have got the tumor in label 2, so label 2 elements will be non-zero, otherwise every element will be 0 with the help of is_member function, and that's how we have got the tumor out here. And we are actually dilating the tumor here. Dilation is nothing but adding pixel to the boundary so that we can get a better view for that. So we have actually dilating it here, and in case we have got the tumor, then I am showing here the image before processing, and after we have got the tumor, like in the middle portion that I was showing earlier. And in the next for the third plot, actually I am trying to get what I want to do. I want to actually, let me show you once again. Like so what I want to do, I want to get these boundaries and I want to encircle it. So that is what I am trying to do here. I am actually trying to get all the boundaries out here, and I am displaying the image initially, and for that I am just holding this image, and while holding it I am drawing, this is for Y stands for yellow, and I am encircling it, like I am drawing a line out of the circumference. And this is how I have got the output, and this is my output. Let me show you once again. This is my output for image. If there is any tumor, and if there is not any tumor, then I have already shown you. So thank you.